So this video we are going to discuss about the regression. Here we are going to take only two variables. Okay, y is equal to mx plus c, and which is your linear regression. So our question is, does score depends on the beauty score? Okay, so does the score student grade depends on the, or does the grade of the teacher? Okay, let's take this example based on the um, does the score of a student depends on his beauty? Okay, so based on that we have this table where we have the id of the user of the student, age of the student or the teacher you will say, and beauty score of the teacher or the student. Okay, gender and everything, but we are considering only two fields here, score and the beauty score. So this will be x and this is y. If the beauty score is high, does your score will be high or less? We will see, we will going to analyze this. Okay, so we have taken only 5 sample. So this is r. Okay, I'll share everything with you in the description, this sheet. Okay, so we have selected only three fields, id score and um, beauty score or the beauty average score and the age. And here we are going to do the calculating the mean. Okay, and the medium. So mean score. Okay, mean beauty score, medium beauty score, mean score and the medium score. Okay, so if all are in the approximately same. Okay, score and your beauty score are lying on the same line. Okay, so if I do the skim, it will tell me this data. Okay, so here we have selected only two fields, so it will going to do the skim of the two fields, which is it will tell you the mean. Okay, standard deviation one from each other, and from the mean this is the first percentile. Okay, so data is lying from 1.67 to 5.5. Okay, which is something like this, majorly data is lying here. Okay, so this is kind of normally distributed, and here the data is lying from 3.8 to 4.6. Okay, which is your left skewed. Okay, so now you can see, you can get some idea of the data. And if you want to do the correlation, okay, is there any correlation between the beauty score and the score? So it is 0.1, which is very very less positive. Okay, positive mean the graph is in increasing side. Okay, linearly increasing, but it is very, the um, the rise is very less. Okay, if the score is high, it does not mean that your beauty score will be less. If your beauty score is high, it has a very slight increment in the score. Okay, this is what it tells you. So if you summarize this data, summarize will do the same thing of the correlation. Okay, now if we do the if I do the scatter plot of beauty score and the score, so it will be similarly like this, which is, it is, I mean, it is all scattered, it is not saying anything. Okay, and that's why the correlation is very low. And if you see here, this is not needed. Basically I have just plotted the beauty score, just to tell you that majorly the data lying between 3 dot something to 7. Okay, or 6 dot something, right? So this is a regression line I have drawn. Okay, out of these two, teach score and the beauty score. So the regression line is going like this. Okay, and in the regression table is something more interested, because it is, if we want to calculate the intercept, y is equal to mx plus c. C means your constant or the intercept. Okay, m means slope, if I want to calculate the slope. So this is your intercept, and this one is your um, m. Okay, mx plus c. So this is your slope and this is your intercept. So if you put, if we want to calculate the y naught, which is y is equal to mx plus c. Okay, so y naught, this is the score naught, score hat we will say. Okay, so residual error is what we have score and what is the actual score, which is coming from placing the intercept and the m, okay, which is the slope in this y. Okay, so taking an example, we have a is equal to this. Okay, this is a plus b into x, y is equal to mx plus c. So a is the intercept, b is 0.67, and if we place the value of y, which is your beauty score, which is, let's say your beauty score is 5. Okay, let's say your beauty score is 5. So if we put your beauty score where it's the beauty score is, I don't think it is coming up here. Okay, 4.7. Okay, let's say okay, this is not the correct example. Let's say the beauty score is y, so it is calculated as 4.25. Okay, but let's say your actual score was coming 4.7. Okay, let's take this example. So it was coming up as 4.7, and but actually by placing the value it is coming as 4.2.15. So this is your residual 0.485. Okay, so how can we calculate the for the whole data? It is the function is get regression point. Get the regression point will tell you the score hat and the residual. Okay, so similarly, if the beauty score was 5, right, if the beauty score was 5, your y naught was coming 4.215, 4.2.1, but the actual was score was 4.7. So the residual is coming 0.86. Okay, so maybe your data was there, but the regression line is coming up at it here. Okay, so the difference is the residual, we will say. So the line came that it is the if you do the sum of all the residual, the sum of residual will be 0. Okay, so that's why your and based on that your line will be drawn. Okay, this is the one thing, regression point hat. Okay, these are all the points, and the other thing is um, okay, let's say if we have multiple fields, okay, multiple for the multiple regression, here we have only score and the beauty score, but here we have multiple countries. Okay, for multiple countries it will pick intercept based on the alphabetical order of your country. So here it has considered it as first based on the data, it has selected your Africa as the base point. Okay, because in the alphabetical order. So if you plot the data for Africa, the life expectancy is this much. Okay, America is this, right? If you do want to do the box plot, so for Africa it is very less, the life expectancy. For the other continents we have very high. This is the mean, maximum, right? Similarly, and the main thing is, so for the get regression point, it has calculated everything based on considering the Africa as the base point. Okay, so if you see here coming Africa as the base point, get regression table, intercept is coming 54.8. For America it is 18.8. So if we do 1854.8 plus 18.8, it will be coming up as 73.6. Okay, so this is how the multiple regression and the regression we do in R. Thank you.